So in this video, we're going to talk about how to solve absolute value equations by graphing. So we already talked about how to solve absolute value equations algebraically, and then in this video, we're going to talk about how to solve these equations by graphing. So here's our strategy when we're solving absolute value equations by graphing. We're going to treat both sides of the equation as two separate functions, and then we're going to look for intersection points to figure out the solutions to the equation. So here's what that looks like. Suppose we're solving the equation the absolute value of 2x minus 10 equals 6. So we're going to take each side of this equation and treat it as a separate equation. So we're going to type y equals the absolute value of 2x minus 10 into our calculator, and then y equals 6. So then you can see here, this is what it looks like in Desmos. We have y equals the absolute value of 2x minus 10 and y equals 6. So then in Desmos, we can find the intersection points. And you can see here there are two intersection points. So we're going to have two solutions to this equation, and those two solutions are going to be x equals 2 and x equals 8. So notice that the x coordinates are what tell us the solution to the equation. So remember, when we're working with absolute values, there are several different possibilities that could occur. So suppose we're solving the absolute value of x equals c, where c is some number. So in case one, if c is a negative number, there will be no solution, right? So if we're solving the absolute value of x equals negative 5, so the left side of the equation, that's graphed here. We have y equals the absolute value of x. And then the right side of the equation, y equals negative 5, is graphed here. Notice that these two graphs will never intersect, so that's what tells us we have no solution. So if we have c equal to 0, so like if we have the absolute value of x equals 0, we know that there's one solution, x equals 0. Well, if I graph the left side of the equation, y equals absolute value of x, and the right side of the equation, y equals 0, notice that there is one intersection point at x equals 0. And then if c is a positive number, like if we have the absolute value of x equals 4, we know that we'll have two solutions, x equals 4 and x equals negative 4. So if we graph the left side of the function, y equals the absolute value of x, and then the right side of the equation, y equals 4, notice that we have two intersection points. The x coordinates that correspond to those two intersection points will be negative 4 and positive 4. So we have two solutions. So to solve absolute value equations by graphing, we're going to start off by isolating the absolute value using inverse operations. So the absolute value needs to be by itself on one side of the equation. Then we're going to enter each side of the equation into Desmos and look for the intersection points. The x coordinates of the intersection points will be the solutions to the equation. So let's try solving now the absolute value of x minus 3 equals 10. So here the absolute value is already isolated, so I can go ahead and enter this into my calculator as two separate functions. So I have y equals the absolute value of x minus 3 and y equals 10. So I'm going to go to Desmos now, and I'm going to enter these into my calculator. So I have y equals the absolute value of x minus 3, and then in row 2, I have y equals 10. So now I'm going to click on my graph to find the two intersection points. And so I have intersections at x equals negative 7 and x equals 13. So those are going to be my two solutions. And remember, you can always check your solutions by plugging them back into the equation. So if I plug in negative 7, I get the absolute value of negative 7 minus 3 equals 10, which tells me that the absolute value of negative 10 equals 10, which is correct. I can also check 13. I do the absolute value of 13 minus 3, and I'm checking if that equals 10. And that means that the absolute value of 10 equals 10, and that is also correct. So now let's try another example. Let's try the absolute value of 2x minus 3 minus 4 equals 3. Well, notice in this case, the absolute value is not by itself, right? It has this extra fluff with it, right? It has an extra minus 4 right there. So we need to get rid of that first before we can go ahead and work on our calculator. So to get rid of that minus 4, I need to do the opposite. So I'm going to add 4 to both sides. So when I do that, I get the absolute value of 2x minus 3 equals 3 plus 4, which is 7. So now I'm going to enter this in my calculator as two separate functions, right? One for each side. So I have the y equals the absolute value of 2x minus 3 and y equals 7. So I'm going to go ahead and go to my calculator now and type those in. So I have y equals the absolute value of 2x minus 3, and then I have y equals 7. So now I'm going to click on those 2 points and find the solutions to my equation. So I have my solutions are x equals negative 2 and x equals 5. And so those are the solutions to this absolute value equation. So now let's try this example. So once again, we have a situation where the absolute value is not by itself, so we need to do that first. So notice that it's not by itself because I have this 3 and I have this minus 5. So remember, when we're solving equations, generally we want to do the add or subtract before we do the multiply or divide. So I'm going to start off by adding 5 to both sides of this equation, and that's going to give me 3 times the absolute value of 2x plus 6 equals 7 plus 5, which is 12. Now to solve, I need to go ahead and divide both sides by 3. So when I divide both sides by 3, I get the absolute value of 2x plus 6 equals 12 divided by 3, which is 4. So now I'm going to enter both sides of my equation as two separate equations in my calculator. So I have y equals the absolute value of 2x plus 6 and y equals 4. So now I'm going to go to Desmos and type these in. So I have y equals the absolute value of 2x plus 6 and I have y equals 4. So now when I click on my intersection points in Desmos, it gives me my two x values. So I have x equals -5 and x equals -1. And those are the solutions to my absolute value equation. So now you can go ahead and pause the video and try doing this example on your own. So remember, in this equation, we want to start off by isolating the absolute value. So when we isolate the absolute value, we get the absolute value of 2x plus 3 equals 1. And so we're going to enter this in our calculator as y equals the absolute value of 2x plus 3 and y equals 1. So that's exactly what I've done here. And so now in Desmos, I'm going to click on the two intersection points, and that's going to give me the two solutions to this equation. So I'll find that the solutions are x equals -2 and x equals -1. So remember that you can solve absolute value equations by graphing. Once the absolute value has been isolated, you can enter each side of the equation as a separate function in Desmos and look for the intersection points. The x-coordinates of the intersections will tell you the solutions to the equation.